So good morning, distinguished guests. It's a pleasure to be here. Thank you very much to the Association and to the Federation for the invitation. I hope I can live up to the invitation with the presentation. So thank you one and all. I'd just like to try to describe today the role of certified compostable biopolymers or bioplastics and their role in enabling the circular economy. I struggle sometimes to explain this concept in the Hong Kong context, given that our view for biopolymers and circular economy requires an end of life for agriculture. And it's a little hard in the Hong Kong context to describe an agrarian economy and things of that nature. But nonetheless, I hope to give you a bit of an idea on where biopolymers might assist you in at least diverting some resources from landfill or perhaps indeed incineration. But first, a short introduction to BASF. So BASF, our claim is we create chemistry. In our daily life and in our working life, everything we try to do is to show paths where chemistry can improve the humanity. Our chemistry is used in almost all industries, and you'll hear from a colleague of mine later today from a totally different business unit, but related nonetheless. We combine economic success, I'm sorry Mark if I'm stealing your slides, but we combine economic success, social responsibility and environmental protection. Sales in 2017 combined were roughly 65 billion euro, with an EBIT in 2017 just a little over 8.5 billion euro. We have around about 120,000 employees around the world, and we have 6 what we call Verbund sites, which means completely integrated. And a simple explanation of that, drawing on the circular economy example, is the waste from one process becomes the feedstock for another. So where we can, we recover resources to reuse them in whatever way possible to create new products. And we have 347 other production sites around the world. So it's a significant footprint. I'd just like to add quickly the biopolymers business, for which I'm responsible for Asia Pacific, is a very small part of the overall organisation. So the current challenges globally, I'm sure you'll agree, we have 9 billion people on the planet by 2050. And if you read the popular press towards the end of last year, it's not 9 billion anymore, it's 10. We're pushing towards 10 billion by 2050, so the problem gets more stark. And it's as simple as how are you going to feed all these people if we keep throwing all the resources away? Hence my comments about agriculture. The story for biopolymers begins and ends with soil. What we take from the soil, we need to put back in the soil. Soil provides food, balances the environment, and many other attendant benefits. And if we continue to waste these resources, it's a huge problem. And I think the figure which I haven't drawn on in today's presentation is some 38% of food is lost before it even gets into the supply chain. And there are some staggering statistics about what that is economically, but just think that 38% of everything we produce on the planet defined as food doesn't even make it to a table. Yet we spend all the energy, all the labour, and all the resources to produce it, to throw it away. Drawing on the theme from this conference of Go Smart, Go Green, Go Innovation, just touching on BASF's commitment to innovation, and this is the broader BASF group. I wish biopolymers would spend this sort of money just on biopolymers, but it's not the case, it's on BASF more broadly. We have expenditure for R&D of roughly 1.9 billion euro, which is a significant commitment. We have around 10,000 employees worldwide, they may be wild, but worldwide engaged in R&D on various projects around the group. About 3,000 new research projects, roughly each year, with around 800 new patents filed every year for these innovations. And a lot of them are patents or research projects that look in how BASF describe things as mega trends. So we look at mega trends as 50-year time horizons. Not so much what's the need today, although that's very important, what's happening 50 years from now. Is it human mobility? Is it environment? Is it water? Is it energy? What may it be? And what is it that may be required where chemistry and science can provide those products, raw materials, or whatever it may be. Engagement with industry, startup companies, etc., etc. So we're not definitely a short-term thinking company, and hence we've survived for well over 150 years with this kind of ethos. Also in innovation, we want to be the most attractive partner for our customers. Without our customers, we don't have a business. It's great if we have innovation and projects and products, but if no one wants them, what's the point? So we engage heavily with our stakeholders up and down what we describe as the value chain. You know, with stakeholders to the left and right of BASF, who will use our product, who needs our product, what are the future needs of society and environment, and how can we build these into successful products and collaborations. We aim to remain the most capable and most innovative chemical company in the world. This is something we strive on every day with our employees' commitments to come up with new ideas and identify these needs through the collaboration with our stakeholders. We want to increase our sales from these innovation products. Old products don't last forever. By definition, they're old. We need to find new products that satisfy these needs of the future. To give you an example, in biopolymers, these are not new products. These have been around since the 80s, but only now are people starting to see the value that they bring. So we've had this commitment and investment, and it's an expensive investment, for many, many years. But only now are governments, local governments, municipalities, consumers and community groups starting to see, wow, throwaway society is unsustainable. We have to find a way to recover these resources. To touch on certified compostable biopolymers, and I stress certified compostable because with certification you get the guarantee of biodegradability. And biodegradability, I'll touch on, means consumption by microorganisms, not fragmenting under sunlight, not disappearing or being triggered by UV and breaking into microplastics. We're talking about consumption by microorganisms into CO2, water and biomass. Not plastic fragments that go into the sea, nothing. Very important, I'll touch on that. But first I wanted to show you, to give you some context to biopolymers. Because when you come to plastics conferences, often you hear people say, oh, beautiful, we'll just make it biodegradable and it will go away. It doesn't quite work like that. To give you context, the global plastics production is something of the order of 350 million tonnes. It's a big number, huge number. Yet the capacity for biopolymers, both biodegradable and non, because not all biopolymers are biodegradable, is just a little over 2 million tonnes. So if you're expecting this 2 million tonnes to satisfy your 350 million tonne problem, there's a little bit of a problem. So I stress biopolymers are niche products designed to address very specific problems. And when you talk about biopolymers or biodegradable polymers in packaging, you're not going to solve all of the throwaway packaging issues by making them biodegradable because there isn't enough product. Now, investment in the industry is expensive. It's hundreds of millions of euros. No one's going to spend that to suddenly make it a 100 million tonne marketplace. Highly unlikely. To give you this here and to talk on this, I heard people talk about bio-based, non-biodegradable, biodegradable. I'd just like to look at this chart quickly. Bio-based, non-biodegradable, think bio-based PE, bio-based PET, PA, all of these other plastics that are fully made from renewable resources. You know, corn, sugars, fermentation, whatever it may be. But they're not designed to be biodegradable necessarily. They're designed to be recycled alongside their conventional plastic counterparts. A bio-based PE is chemically identical to an oil-based PE and can be recycled exactly the same way. But the challenge may be collecting it to recycle. It's very hard to collect very thin film. Yeah? It can be done, but you need an awful lot of it to sort of make it economically recyclable. On the other hand, what you can see there for fully biodegradable materials is significantly less than the bio-based alternative. Yeah? So I hope that's clear, is that you've got 100 million tonne problem, but only a 880,000 tonne solution. So it's designed to be very specific in addressing the end of life problem it solves. So as I said, not all biopolymers are biodegradable. To the left of the screen, you'll see the bio-based products designed to be recyclable along conventionally with their counterparts. So PE, polyamides, polypropylene, etc., and others. And below you'll see their conventional cousins, PE, PP, PVC, etc., non-biodegradable but maybe recyclable. To the right hand you'll see an example, which is BASF's EcoVeo, which is a partially bio-based, completely biodegradable material. We talked about PLA, or I heard PLA mentioned this morning. It's also there, along with PHA. And to the bottom right-hand quadrant, but based on oil, are based products such as EcoFlex and PBS. Yeah? Eminently biodegradable, different feedstock. The important message here is the feedstock plays no part in the ultimate biodegradability of the material. Doesn't matter if it's based on oil, doesn't matter if it's based on renewable oil, renewable content, or bits of both. It's either biodegradable or it's not. Okay? Feedstock plays no part in determining that. EcoVeo, which is EcoFlex, or PBAT, as you may have heard of, plus PLA, combined creates EcoVeo. Fully biodegradable, partially bio-based plastic. Certified globally to all standards for compostability, because within compostability standards come two tests. One is biodegradation, or consumption by microorganisms, and I stress that test is pass or fail. There's no half pregnant here. You either get over the line or you don't. But yes, certified all the same. Yes, and disintegration, I beg your pardon, the other part of the test. So once the biodegradation is completed, the biodegraded material is then subjected to a disintegration test, again pass or fail. Now you'll hear lots of oxide materials and other additive conventional plastics claiming to be able to meet these standards, but they simply cannot because they cannot pass the biodegradation part. Therefore they cannot go to disintegration, therefore they cannot have pass. They have failed at the first hurdle, end of story. So, touching on what are the global standards for compostability, which will prove the biodegradability of a biodegradable polymer. You have the European norm, 13432, you may be familiar with. You have Greenpla as an example from Japan, although there are others. ASTM D6400 from North America. There are Canadian ones as well. And the Australian standard is in there as well, which at the moment is the most stringent standard on the planet. And the simple reason for that is the Australian standard includes an ecotoxicity test for worms. The reason for that is if you are going to put a biodegraded biopolymer back into agricultural soils, you better prove it doesn't harm earthworms, which are considered critical to soil health. Now, people laughed at Australians 10 years ago on this standard saying it's too much. We said, no, we need to have this. The farmers are saying, if you want biodegradable polymers for organic waste collection or compostable packaging or mulch films or whatever going back into the soil, you better convince us there's no damage to the earthworms, which are critical to our soils. So we created an ecotoxicity test to, again, pass or fail. Here we are 10 years later since the Australian standard was created. ASTM are thinking about putting it in theirs. It's in the biodegradable mulch film standard now. It's being adopted almost universally as a necessary part because people are saying, wow, soil's important. Yeah? Can't grow much wheat in the ocean. Can't grow much other things in the sea. Soil is pretty critical. So circular economy, trying to describe how do our products play their part in this, which is such a huge topic. You know, it's not the sole contributor to circular economy. Circular economy is a big topic. It really is a very large topic. And if you've been following Ellen MacArthur Foundation the last few years, amongst everybody else who's talking about circular economy, there's many infographics and descriptions on what the process is or should be, moving from linear to circular, from this to the other, I think sometimes it gets a little overcomplicated. If you ask yourself, is it okay to use something once and simply throw it away again and again and again, and then multiply that by 10 billion people? It doesn't make sense. It's a fairly simple test I think we can apply at home. It doesn't make sense to do this. We should reuse things more than once. Yeah? We don't drive our car once then throw it away. A little extreme, but you know what I mean. We need to use these things a few more times. And what you'll see in this, and you're probably familiar because it's been around in the press, is that there are two cycles to a circular economy. There's the technical cycle and there's the biological cycle. And I'm drawing largely today on the biological cycle, obviously where we can play a role with our materials. And largely that's by the source separation of food waste in commercial, home premises, whatever it may be, and putting the clean organic waste out for separate collection and processing back into something that can be returned to the soil. It's not important whether that process is composting or whatever it may be. It could be anaerobic digestion, it could be biogas, it could be any kind of what we call organics recycling. And this recycling doesn't mean that the products need to be organic in nature. They don't need to come from organic farmers. All of these organics are carbon-based. Think food waste. And if you create this biological cycle for reprocessing of food waste, you at the same time create an opportunity to recycle organically compostable packaging. Now, it's very hard to collect and process packaging alone, because how do you distinguish a compostable package from a non-compostable one? It's much easier if you say, right, let's get everything being source separated food waste wise, or that organic stream established. Then you say, right, when we break all the packaging into its bits, like flexible film, paper coated, this or that, rigid or whatever it may be, bit by bit you can start making those particular packaging streams compostable, and they go into the same organics waste stream. This is a long-term thinking. You won't do it overnight. For example, India created 3 years ago compostable packaging regulations that were meant to be enforced from April of 2018. And do you know how much compostable packaging is in the Indian market? None. Simply can't be done holus bolus across a country, because in the case of India, there isn't any organics recycling to take the compostable package. It's still going to the landfill, it's still going to incineration, it's still being thrown on the streets or the rivers, wherever it may be. So what's important here is having the infrastructure, or at least investing, I heard that this morning, in the infrastructure to receive these materials and process them. And I was here in 2009 at the start of the blueprint discussions on Hong Kong's waste problem. And I was asked the question, Mr. Williams, if we compost all of Hong Kong's organic waste, we will have thousands of tonnes of compost. What will we do with it? Yeah, and it's a really good question. So my point here is, no one's saying compost all of it, but surely taking 10 or 20% of it out of a landfill, or taking 20% out of it from an incinerator and making it into a higher beneficial use makes more sense, or whatever that percentage may be. But certainly better than none. No one's asking for 100%, but it makes more sense from a CO2 sequestration point of view, or a soil improvement point of view, or an urban amenity point of view, whatever it may be. It's certainly better to reprocess those things than simply dump them in the ground to generate methane, if you're not recovering the methane. So I'll touch a little on this biological cycle and where we are. I'll stay away from the technical side because that's not sitting next to a professor. I'll let them discuss the technical sides of things. So I've probably described some of this now, but I'll put it up. I won't go through all of it. But where the complete biodegradation is ensured by the certification of these materials, you can return that resource to the bioeconomy. So think of the bioeconomy as the biological cycle within the circular economy. And in the case of Europe, in some countries, were you to collect all of that organic waste and reprocess it, you create 20,000 jobs. And I've never met a politician who said, gee, I don't want to create jobs. I don't want to create employment. I don't want to create investment. So if you think about this as a part of the recycling stream that's kind of not thought about, we all think about conventional recycling and mechanical recycling, and somehow this kind of organics recycling is just left over there because it's too hard. It's not. There's lots of technology on the planet that can process these materials cleanly, efficiently. You can get energy out of it. You get free electricity for the investment. Now, being again a little extreme, but think about this. And I am pleased to see in some of my discussions here with government officials and people in Hong Kong, that green light has gone on. It's now no longer a no-go zone. It's something they wish to explore, recognising the land limitations in Hong Kong that you can't possibly, reprocess everything one way alone. You need a combination. So, all of these things here is that, critical to a circular economy, or a sustainable circular economy, resource recovery systems. So look at these recycling things as resource recovery, not waste management. Going on a diet is waste management, yeah? But looking after these things is resource recovery. And if you think about compostable biopolymers in packaging, it also goes beyond that into films, injection moulding, thermoforming, and even biodegradable foams to replace the ubiquitous white polystyrene. These things exist today. Again, certified compostable biopolymers, and I keep stressing this because when you get people approaching you saying, I've got a biodegradable biopolymer, you want to ask for their certificates. You want to ask for their proof that it is. And if they can't provide that proof, you should ask, why not? Yeah? Because 95% of the real players in this marketplace today have it all. So their customers have it all. And if they can't provide you that certificate showing it's been tested and proven, you should simply say, why not? It's a little like the intent in some countries to have a 50% recyclable PE, plastic bag, with 50% biodegradable content. Well, it's not going to biodegrade, and it's not going to be recyclable, and it's going to go to the landfill. So you're not achieving very much. So again, let's get out of this half-pregnant mentality and say we're either going to have all recycled or we're going to have all certified biodegradable, one way or the other. I want to stress that this biodegradation is a natural process. When it comes to certified compostable biopolymers, whether it's EcoVio from BASF or certified materials from our customers and competitors, it's a biological process. We don't need any additives. We don't need any special triggers. We don't need any other chemicals added to make this thing do what naturally it will do. In the presence of microorganisms, they will consume these polymers. Yeah? Proven globally for about 20 years. So again, please look for the certificates on these materials, whether it's ours or somebody else's. There will be no residues left behind but water, CO2 and biomass, or if you like, think humus or compost or some form of completely organic output as a result of this biodegradation. Give an example of some of the applications, bearing in mind that we don't have enough supply to be able to do all of these things at the same time, but these are some ideas because in different countries different things come up at different times as to what's important. I mean, 5 years ago it wasn't marine plastic pollution, it was we need to get this stuff out of the landfill. Our landfill is filling up, how do we solve this problem? And the answer at the time was stop putting the food waste and anything organic in the landfill, because 50% of everything you put in the landfill today is organic. If you stop doing that, you've just doubled the life of your landfill. Yeah? So now you've bought some time to think about how you deal with the problem of the landfill by processing the organics a different way. Now, if you're a waste manager and you're running a landfill, and I now say your contract's not 40 years, it's 80 years, I don't think they're going to be unhappy. Yeah? So these are the thought processes you need to have. Some of the examples you can see here start simply with waste bags, garbage bin liners, whatever you like. That's the real low-hanging fruit. You can do paper-coated coffee cups to replace the PE, which today can't be recycled, unless you extract the PE from it, which is a complicated process. I should never say cannot be done, let's just say hard to do. Yeah? Because in China, I've learned if you tell them cannot be recycled, 5 minutes later they say, we've built a plant, we can do it. So be very careful of cannot. T-shirt, retail bags, again, all these things are quite simple. Can be used as an impact modifier to increase the renewable content in other materials, for example. Cling wrap is another new one we've got. I don't know what it is here, but you have the Glad wrap or the PVC film, whatever that goes over, can be replaced with a cling wrap. Also very handy if you have food banks. Because if food banks take food that's past its use-by date from supermarkets or wholesalers, retailers, whatever, if that is a compostable tray, so a thermoform tray, with apples in it, with a compostable film over the top, after it's left the supermarket to go to the food bank, and the food bank can't use it to give it to somebody, the whole thing can be composted without even being unpacked. Because a lot of time in these recycling things is taking it apart, saying, can't use this, can't do that, this is the only bit I want. So in this context, you can do the whole thing all at once. Mulch films is something I won't touch on today, but this is a huge global market for BASF, replacing thin polyethylene films that generally are not recovered and recycled simply because they're thin. They've been in the field for 6 months or longer. They're covered in dirt, fertiliser, pesticide, herbicide, whatever else it may be, and they're 4 micron. Very hard to recover. But a biodegradable mulch film biodegrades in and on the soil to exactly the same things I just described as for a waste bag. CO2, water, and some biomass redeposited back in the soil. Don't need to collect it, don't need to do anything with it. Plough it back into the field, lay it out again, plant again and harvest. The cycle continues. Again, circular economy contribution, reducing your labour costs. Food packaging we've touched on. Netting is also part of that food packaging, so think onion bags or nylon bags, things of that nature. Injection moulding. We have a lot of projects running around the world on various types of injection moulding solutions, caps, closures, things of this nature. Thermoforming I've touched on briefly. And the only one I'm not showing there is the certified compostable EPS replacement, which we also have and have only recently sort of launched, but already it's certified compostable processes through an organics recycling plant, just like a film. I think BASF would say since we gave the world polystyrene 85 years ago, we'd also like to give the world a solution for polystyrene. I'd like to, in circular economy, I'd like you to think of circular economy in the context of biopolymers as a nutrient loop. What you take out the soil needs to go back in, as I said at the beginning. Story begins and ends with soil. You'll see up the top there, it's all about agricultural inputs and outputs. Probably should start with outputs first, because that's what we take, and the inputs come the other way around. But as you like. Then think about distribution and consumption of the packaging. The shopping bags, the food itself. The waste generation collection, what you throw away, how it's collected, what goes on, films and packaging. I call it compost production, but it could simply also be anaerobic digestion, where there's compost as an output of that. And there's many different ways of doing organics recycling, large and small. It doesn't need to be a 100 million euro stainless steel black box. It can be very agrarian, on farm, and done very simply. With some old car tyres and a 10 square metre tarpaulin. It could be that simple, or it could be that complicated. But the output nonetheless is organically rich, non-toxic and safe if processed correctly, goes back into the soil to produce more food, improve yield, reduce water, reduce fertiliser consumption, and a raft of attendant benefits, which then allows us to grow more food. Think of that as the nutrient loop. The nutrients we take out, we need to put back in. So just showing some of these things, recognising that there are other solutions when it comes to circular economy. Landfill is probably the least preferable end of life for materials, but it does serve a purpose. if what we landfill happen to only be something that we've taken every single resourceful value out of, it's probably not such a bad thing. You may not be as old as me, but in the 60s there was a book called Mining the Landfills, where someone predicted there will be a time where humans will go back over what we have buried and dig it up again because we'll need it. And along comes the early 2000s when China's going crazy, and guess what was happening? People start stealing the copper and things and digging up old car batteries because they need the lead. And you may have had the same phenomenon as the US and Australia where people are stealing the copper from the railways. Yeah, because all these things that we've thrown away suddenly have a value again. So the landfills are getting dug up to find what can be sold again. Funny, but happened. Probably happened again. But what we want to think about here first, when it comes to whether it's the food waste, biopolymers, or consumption of anything, let's start at the source. You know, you've heard the reduce, reuse, replace, etc., all the 3, 4, 5, 6 R's. Let's start at the source and reduce what we need. Do we need 10 or can we get away with 5? Yeah? When it comes here, should we feed hungry people with waste food before we throw it away? Should we feed animals? Is there an industrial use? Composting is an option. It's not first, it's not last, it's an option. But landfill's probably the last card in the deck when everything else has been done. So some examples of those. First of all, reduce the volume of surplus food we generate or take. Divert the extra food to food banks, etc., as I said. Divert food scraps to animal feeds. The animals need to be fed if we're going to eat the animals. We need to look at waste oil for rendering, digestion, energy recovery, biofuels, all goes on. We need to create nutrient-rich soil amendments for agriculture. It doesn't have to be a compost. I know compost comes with negative connotations sometimes. But an organic output into agricultural soils that's clean, pathogen-free, doesn't have weed, seeds and other nasties in it, is an extreme or higher beneficial use than the next step. Probably the issue with landfill or indeed incineration for wet waste or organic waste is the inordinate amount of energy you need to dry the wet waste to be able to burn it. Touched on that. You probably get the message we're pretty in favour of composting. If I haven't made that point, please let me know. On this topic here, when you've done everything else, once all steps have been covered, source separation is very easy in the home and commercial premises, so it's not just the home. Waste bags from the certified compostable, biodegradable Eco-VO. They enable clean, hygienic source separation. They don't leak. They're far preferable to a paper bag because the oil doesn't come out. The liquid doesn't come out. We found in Europe, particularly in Germany in some studies, if you have food waste in an Eco-VO bag that's stored for say 7 days before it goes into a biogas or anaerobic digester, the biogas generated from that Eco-VO contained material is some 60% higher in biogas recovery than if it's just stored on its own raw. So the phenomenon of these bags is they actually keep the waste fresh, if that makes sense. And it's kind of simple because for them to be consumed by microorganisms, they need to have a structure that's somewhat breathable and allows the microorganisms to consume them. So it makes perfect sense that waste in a bag would breathe and stay a little bit fresh, yet still retain odour. So that when it actually goes to a digester to be processed, it's still rich enough to generate strong biogas. Just to show that we have a balanced hand on these things and no one solution is better than the other. Just to give some examples here on CO2 emissions from the various processes. Taking a kilogram of organic kitchen waste, landfill, incineration, composting. If you landfill that, over time, between 2.4 and 2.9 kilograms of CO2 are emitted. Okay? If you incinerate it, around about 1.7 to 2 kilograms, or slightly above, kilograms of CO2 are emitted. Composting is not immune to CO2 emissions, but it's significantly less. So I'd argue with a CO2 or a carbon economy, If you want to reduce your emissions, you'd want to send as much this way as you could. Yeah, because for every 5 of this you do, you can reduce that by 5. Again, just food for thought, no pun intended. What we've also discovered in this circular economy journey we've been on about how to keep things moving around and stop throwing them away, one of these unintended consequences is that EcoVeo extends the shelf life of various fruits, which we weren't quite expecting. So in the study we concluded recently, what you'll see here is that without bags, is this first bar, it doesn't show up too well here, but you can see it. EcoVeo bags, sorry, it's the wrong way around. HDPE bags, EcoVeo, so 1, 2, 3. Mushrooms, for example, if stored in an EcoVeo bag, in exactly the same conditions, last 5 times longer. Lettuce, 7 times. Bread, 2.5 times. Grapes, 1.5 times. Tomatoes, which I'm rather partial to, it says it was good, 4 times. But not so good with apples. We've got some research to do on why, but obviously the apples emit some things in their process that do various things. That's okay. I would be concerned if all of them were negative. We have some good, strong benefits in here for extending shelf life of fresh fruits when stored in EcoVeo packaging, or flexible film bags, if you look at it that way. We found that quite pleasing. What's good is that at the end of that, you can also peel that or put the scraps of these in that bag, throw it away, compost them more. You don't need to take it out of one bag and put it into another. Just leave it all in one. As you use it, contain it. Bananas was a good one. Bananas was, again, I'm rather partial to bananas. Asia, you rather like bananas too. So bananas stored for 6 days without a bag, so that's the control. 6 days in a PE bag, and 6 days in a compostable thing. You can see that they remain relatively clean, perfect, and good to eat. Again, some of the advantages. When you look at PE, you probably know this. Really good, fantastic, watertight, grease resistant, wonderful material. Nothing wrong with this material. It's just what happens to it at the end of life. When it's thrown away, it becomes a real problem. When it's not contained, it's a real problem. And it's definitely not biodegradable, and it's definitely not compostable. And it doesn't matter what you add to the PE, you're not going to change these properties. You can add all the oxo additives you like, but you're not going to change this. Over here, paper bags, wonderful, biodegradable, compostable, beautiful materials. But try to get to the rubbish bin if you've got oil in them. Yeah? Transport's a bit of an issue. Containing the waste is a bit of an issue. Yet up here, with EcoVeo, you get the best of both worlds, or all 3 worlds if you like. Some examples of where we've piloted this around the world. We've done pilot projects that we've sponsored in Wuhan, in China. We did some projects in Pune in India, because it's fine to talk about this, but until you take it to the people and say, use these bags, use these packaging, source separate it, let us collect it, process it, and put it back in the soil to prove what we say works. It has no value. So we've done this hand-on. And what we've done in India right now is we have a community in West Bengal where we've done around 20,000 people, and we're processing, will by the end of this year from the whole community, some 3,000 to 5,000 tonnes of organic waste. So starting from literally going door to door proving the value of these materials, they'll become a zero waste community. And so it takes a bit of leadership from government and big picture vision to see that these things can be done. And I'd also advocate it's easier to do in a smaller community, small size city, than trying to say, for example, take Hong Kong on. You have multi-user dwellings, it's a very mixed landscape, so I recognise the difficulties. But for every one you take off the landfill grid and do something beneficial with is another good step in the right direction. So a journey starts with a simple step, or single step. Australia, we've been doing this for 10 years now. And now, because we also have some government people that take a long time, in fact we have government people that change too often. That's our biggest problem, is having them in power long enough to have a conversation with them. Because you have a meeting with them and then discover it's his predecessor, or the predecessor's gone, you've got a new person to start with. Changes every sort of 6 months. But now we also have bans on single-use plastic bags, so we're joining the let's get rid of this single-use stuff and move to a circular economy as well. So, to summarise all of this, and I hope it's made some form of sense, but what I'd like you to think of in terms of organic waste, and I stress, it's only if you create this organic waste diversion can you create the market pull for the compostable packaging, and so on and so forth, that satisfies the needs for biodegradability. If you recognise it's a resource efficiency drive, it's a resource recovery, it's not waste management. You'll find that, putting this stuff back in the soil reduces the dependence on things like phosphate-based fertilisers. Yeah, we're running out of them too. You've heard of peak oil, we've also had peak phosphorus. We're going to run to a time where we won't have these things, yet they're critical as nutrients for plants. Renewable energy source, so using this for biogas production, why not? And also reduced carbon footprint, as we said earlier on. If you want to reduce your emissions, here's one sure way to do it. Change the practice of just landfilling. Cleaner, safer, easier, because you're getting no toxic residues from the biodegradation of the polymer. You know it's proven certified compostable. You'll find that it's very convenient. Promotes the use of compostable packaging once the organics waste stream is started and in existence. And all of these things tend to promote circular economy over time. And I recognise it takes time. So I think that's it for me. A little earlier than time, but I was hoping there might be questions or criticisms. I'll take either. With that, I thank you again to the Association, the Federation for having me along, and again, thank you very much.
Thank you, Mr. Williams. Thanks for your sharing, and please stay. Here comes to the Q&A session. If you have any questions for Mr. Williams, you may raise up your hands now, and our staff will pass you a microphone. Any questions? Please.
Good morning, gentlemen. Thank you very much for your presentation, and the information content in your PowerPoint is very information and helpful to us. Can you do us a favor? Let us recycle your PPT, design us your PPT in PDF so we can get more information from your presentation. Is it possible?
I believe the PDF will be made available after the conference. Yeah, absolutely.
Okay, thank you very much.
Yep.
Any other questions?
Are there any other easy ones like that? Big fan of easy questions.
Thank you, William. I'm Bobby from Federation. So you mentioned about the range of the application of the EcoFlex. Several applications like the coating, the t-shirts, the netting, and you mentioned about the injection molding. Is it possible to make this extrusion or co-injection or compaction molding the other way to produce the material? Because you just mentioned about the injection molding.
Sure.
Are there any application like extrusion, co-injection, compaction molding can make it?
Okay, well I'm not a processing technician. However, for example, co-extrusion is certainly possible. We have co-extruded mulch film. We have various multi-layer other films for packaging. When it comes to other types of injection moulding, I need to ask some questions for you because it's a relatively new application for us. But BASF has a long history of plastics for injection moulding, so it's following that same application pathway. So I'm happy to give you some answers or connections separately, but I don't have detailed information.
Thank you.
Thank you for your presentation. This is Jacko. To have a little bit more understanding of compostable materials, So their compostable material, if it actually goes to the landfill, it actually doesn't digest itself. It doesn't turn into, it doesn't digest. So how the European market does it as in a sense of separating and actually building the compostable? Do they compose, does everyone compose it at home, like in their garden? Or as a country or a city, do they build infrastructures to help this process?
Good question. For the landfill, I just would point out, composting, all these things are aerobic processes. When you go into a landfill, you have an anaerobic environment, so devoid of oxygen. So whilst there will be breakdown, it will be much slower. It will occur, but over time, probably the output would be methane, yeah, in smaller quantities or larger quantities, depending. Obviously, these products, compostable products, are not designed or should not go to the landfill, but they can and they will. But they will break down, but over a longer time frame. In Europe, there are different regulations depending on different countries, and I don't have all the details of every state of the European Union, but the Organics to Landfill Directive prohibits sending organics or food waste or organics to landfill. So they've had to come up with different solutions to process those organics. So for example, in France, certain types of shopping bags must be compostable with a 50% bio-based content designed for home composting. And then there are other variations on those themes depending on the country. Germany has different things, but there's a lot of anaerobic digestion in Germany. There's also a lot of just conventional composting. But different sort of regulations governing where it should go. Does that answer your question? It's all heading in the same thing. Stop sending it to landfill, but different types of processing for the end of life.
Yeah, well, we understand that part, but on the other hand, we're looking at how Hong Kong can do it. There's a lot of education that is involved to the public about all these type of plastics, and there's all kinds of engineering plastics available. How does the public learn and understand and put it in the right place to make this work? Because if it's all going to the landfill, it's all the same.
Yeah.
Well, it's a little bit better, but you actually pay a higher price for it.
Sure. That's, I think that's a real challenge. I mean, I'm not a plastics recycling expert. However, I recognise the challenges. What we found in certain countries is when you stop having this mixed waste and you take the organic fraction out, you're left with cleaner other waste. And for example, that might be PET bottles. And PET bottles, or the reprocessing of PET, is a readily available technology, and many companies have expertise in grabbing that PET to recycle it. In fact, I think today recycled PET or rPET is more expensive than virgin PET, because people like Coke and that want to use more recycled content in their packaging. Therefore, they're driving the market for recycled plastics. So the technology to collect, recover and reprocess those plastics is abundant. How Hong Kong applies that, I've read through the blueprint many times, and it's all incremental changes in different areas. But fundamentally, until you separate or segregate the different waste streams, I don't see how you're going to be able to stop that problem. I mean, if you ended up with one coagulated mess and it goes to one place, no one's going to want to separate the organic from the PET from the... Yes, it can be done, but it's easier to separate at the source. Does that make sense? I know there are companies in Hong Kong talking about, or overseas companies talking about source segregation of the waste at the source to prevent that mixed waste problem. Yeah? Does that help?
Any more questions? This gentleman, please.
Hello, my name is Harry from the Institute of Industrial System Engineers. I recently learned a lot about circular economy and trying to promote it to various industries. And my question is, when I'm learning circular economy about products, I mean, just like your plastic compostable, It is not very easy to promote to the countries, regions like Hong Kong and others, because the price is very expensive. There. So is this the case for this plastic compostable bag? Is it not very easy to promote to other people? Do you have any thoughts about that?
Oh, it's a regular question. Certified compostable plastics are 10 times more expensive than PE, and 20 times and 30 times and all these different numbers. I think you need to look at what you avoid. Now, what are the problems created by PE? And no one likes to look at the full ledger accounting for these materials. So with PE, you've got to produce it, ship it, transport it, use it, collect it, throw it away, put it in the ocean, kill turtles, And if you account for all these things, and on the other side of the ledger say, right, I'm not throwing it away, I'm collecting the food waste, I'm turning it into compost, putting it back in the soil, not killing turtles, saving CO2, What we find if you actually do, they come into equilibrium. Yeah? The best example I can give you is a biodegradable mulch film for PE, very cheap, 4 micron, you can imagine, it's extremely cheap. Yet we sell 10, 15 micron biodegradable mulch film for a much higher price for exactly those benefits.
Give me a very good idea to promote in the future.
It's really about accounting for what you avoid. You know, if you don't have to pick that film up and take it to the landfill, if you don't have to use the energy to burn it, if it biodegrades in the soil, apart from labour and all the other environmental things you find when you discount what you no longer need to pay for or incur as a cost, it brings the things into equilibrium. Also, when it comes to shopping bags, for example, today I don't know about Hong Kong necessarily, have a bag tax or charge here in Hong Kong and other. But what we found in other countries like Australia, the US, people suddenly are willing to pay 20 cents, US cents, for a compostable bag, which is a lot more than they cost. Yeah? They might only cost 3 US cents, but people will pay 20 to have them, to know they'll feel they're doing the right thing. So the cost of the bag doesn't even come into the discussion. If the consumer gets the idea, I can take this bag, I can put my food waste or my packaging, and then I put that into my green waste or garden waste or whatever bin, and it's going away to be processed into an organic output, I'll pay 20 cents for that. That's what we find.
Yeah, I think more people are becoming aware of that part.
Yeah.
So it's a good sign.
Don't quote me on 20, I've seen it at 5, and in the UK has a 5 pence tax on things, and other people have 10 or... The thing is, it will be user paid. The days of getting something for nothing, regularly, routinely, forever, I think are just exhausted. If you want the convenience item, you're going to have to pay for it. And whether that recovers all of the cost or some of the cost answers your question.
Any questions? This will be the last question.
Sorry, I have a lot of questions. Actually, I want to ask a little bit about 50 years from now, from what your research is like. Now we're talking about from an economy of bio-based plastics, now into maybe a plant-based or more compostable material. What is your research tells you that 50 years from now, what is happening? Is there a certain type of material that's coming up, a new way of producing plastics, or material that is going to replace it? What is it going to happen in 50 years if you can tell us?
Gee, that's a good question. In 50 years, I'll probably be an organic input myself.
But you got all kinds of research.
May happen sooner, I'm not sure. Look, there's a lot of... how to answer this? No, I don't know what would be in 50 years from now. I think the more immediate problem in the next 10 or 15, by all accounts, will be marine plastic pollution. Yeah? I don't think for 1 second giving humanity a polymer that disappears in the sea just because we're stupid makes any sense at all. Yeah? That's my first thing. It shouldn't be thrown away and shouldn't end up in the sea in the first place. Unfortunately, you can't legislate against human stupidity, but there we are. I imagine that's the most immediate need at the moment would be to improve the recyclability of the plastics we have today, make it even better than it is, and recycling of plastics today is already good. It's just not universal. Do we need new materials? Honestly, I'm not qualified to answer. Demand will drive what's needed. I would suggest that a better usage of what we've already got may be the answer to your question. Finding a better way to make, use and reuse those materials would probably be the direction we're heading in. And in the case of BASF, and I'm again not an expert on this, but things like chemicycling, the chemical recycling of plastics into other materials to reuse problem plastics is probably a good solution rather than throwing them away. So I think if you've got polymers and plastics that serve a very, very valuable functional purpose up front, think blood bags or essential uses, it's very hard to find replacement materials for those. But you can't reuse them. So I think finding the reuse possibilities for problematic plastics is probably where the research is and will drive, I guess, the next 10, 20 years. That's where I think, anyway. BASF could come out tomorrow and say something completely different, but I think that would be the answer.